All right, this is pre-calculus section 1-2. It's day 2 of this section, and today what we're going to do is we're going to find the domain of a polynomial function and be able to state the domain in using different notation. You should be on page 5 of your packet. All right. Here is just, for your information, basically, a definition of a polynomial. Okay, you've got your polynomial f of x. These are your coefficients, a of n. A of n is your coefficient here. A of n minus 1, a of n base 2, a of 1, and then a 0. So you can see that they go down in decreasing order. Then you got your exponents also decrease in order until it gets down to x to the 0. So that's just a typical polynomial, how it's represented using symbols. N is non-negative. A is a real number, so your coefficients are real numbers. And the degree of the polynomial is n. So it's just the definition of a polynomial. Here's an example of a polynomial. 3x squared, 7x plus 2. Okay? This can be put in underneath the definition of a polynomial function. All right, the domain of a function. So we've got definitions of domain of a function. It's defined as the implied domain of a function to be the set of all x such that the corresponding y is a real number. We will consider there's 3 situations here that we have to use to help us find the domain of a function. And when we find the domain of a function, we find it algebraically. One method is algebraically. Okay. Here is a polynomial right here. You've got some examples of polynomials, but a polynomial, the domain of it is always all reals because it doesn't matter what you put in for your x's here. You're always going to get an output. You can put anything in for your x, any real number. There's no restrictions at all. So in that case, your domain is all reals. And now this is going to, I'm going to show you, or this indicates here, what your domain can be written as, the symbols here. This is your infinity symbol. And so by using the infinity symbol here, this says from negative infinity to positive infinity, and that means all reals. All right? So for all polynomials here, all reals, the domain is all the time. Okay, now, second situation is when you have fractions. If you have a fraction and there's a variable in the denominator, then you have this division of 0 problem. So this 4 divided by x, well, this is true, and this can be a function as long as x is not equal to 0. So you can't divide by 0, ever. It's undefined. Here's how you write your domain. One possibility is saying that x is not equal to 0. Another way to do it then would be to use this notation. So from negative infinity to 0, and then in union with, which means and also, from 0 to positive infinity. So that's another way to write your, using some different symbols, ones that we haven't ever used before. All right, that's the second scenario when you have fractions. How do you take care of it? Well, what you're going to do is you set your denominator equal to 0. In this case, it was just 0. All right, the third scenario is if you have radicals with an even index. If you have a radical with an even index, then you have some things that you have to look for because you cannot take the square root of a negative. So what you'll do is you'll take your argument underneath the radical and you set it greater than or equal to 0 so that it keeps it to be positive. So if this is my domain for this one, then here's my new notation. Greater than or equal to 0. Here's the symbol that you have for equal to. So it can be 0. You use a bracket and then to infinity. But that's what's using some of the new notation is going to be, and that's how looking at some domain issues. And so we're going to go through some examples that give us some problems with either fractions or the square roots. So we're still on page 5 here. Now we're leading into that example 8a. Find the domain of each function. Okay, what we're going to do is I'm going to show you how you can find your domain and write it in a couple different ways. All right, so this is just a regular polynomial. So all reals. There's no restrictions here. Here's how you write all reals using the new notation. Negative infinity to positive infinity. Now with infinity you do not use the brackets because it doesn't stop. It's continuous. It goes on forever. So it's not like we're including an actual number there. It's a fictitious number, infinity. Okay. All right, letter B. So here's our problem right here. We are not able to do 2 divided by 0, and so you take your expression x plus 2 and you set it equal to 0 to figure out what would make that 0, and that would be negative 2. So this is true as long as x is not 2 or negative 2. So x cannot equal negative 2 or from negative infinity to negative 2 in union with, which means together with, negative 2 to positive infinity. So basically this notation says everything but the 2. Okay. All right, we talked about that even index. Here we've got an even index of 4. So when I take the 4th root of 5 minus x, 5 minus x has to be greater than or equal to 0 because you can't take the 4th root of a negative number. So negative x is greater than or equal to negative 5. I'm going to switch my signs. X less than or equal to positive 5. There's my domain. As long as this number here is less than or equal to 5, then I can take the 4th root of it. So that's your domain, x less than or equal to 5 in the new notation from negative infinity up to 5, and since it's including 5, we use a bracket. Okay? All right, let's look at our other examples here. Letter D. So this is a 3rd root. Well, you can take the 3rd root of anything, positive numbers or negative numbers. So it wouldn't matter what I put in for this x. All reals. You may have seen this symbol as well, double R, a double barred R, and negative infinity to positive infinity. See that there's 3 ways that you might see the domain being listed. All right, so example E, so what you want to ask yourself is there anything wrong with the expression? Is there anything that would cause a division of 0? Yes, possibly, or maybe taking the square root of a negative. Well, here you can see we've got a double whammy. Not only does x minus 4 have to be greater than or equal to 0, but it can't equal 0 either because then you're dividing by 0. So I just do x is greater than 0. Makes it positive. I do not include 0 because then you're dividing by 0. So x is greater than 4 then. That's my domain. So greater than 4 would be 4 comma infinity, but not a bracket. Not a bracket because you're greater than 4. You don't want to include it. All right, this is my last one here, and it's a little bit more challenging, and so we're going to go through this one a little slower. The 4th root of x to the 3rd plus 5x squared. Well, you can see underneath the square root, I'm not able to separate these. If I'm trying to figure out this expression right here, x to the 3rd plus 5x squared, how does that become greater than or equal to 0? How do you solve that? Well, when you have extra powers like that, you solve by factoring x squared. Take an x squared out, you get x plus 5. Let's just think about this for a moment. If I'm multiplying 2 things together, x squared and x plus 5, and you get a number that is positive because it's greater than or equal to 0, then there's 2 things that has to occur. There are 2 things that happen. Either both of these are negative or both of them are positive. Okay? Either they're both negative or they're both positive. All right, since we have this type of scenario and we might have multiple answers, what I recommend that you do is you go ahead and solve it. So you set x squared greater than or equal to 0, and you get x is greater than or equal to 0. And then you take x plus 5, and you get that greater than or equal to 0, and you solve it, and you get x greater than or equal to negative 5. Here's how you determine what your final answer is. You take a number line, and you plot these points, negative 5 and 0. I don't really care where you put them, but we're just testing some things. So here's what you do. You decide, all right, well, what if I pick a number that is less than negative 5? So you pick a number over here in this region. Let's say negative 6. Okay? If you put negative 6 in here, if you put negative 6 in, you know, what are we going to get for our result? Negative 6, I'm going to go ahead and put it right here. Negative 6 squared, so we have got 36 times negative 6 plus 5, negative 1. Is that greater than or equal to 0? True or false? That's false, okay? So my solution is not over here. That's false. All right, let's pick a number between negative 5 and 0, like negative 1. So negative 1 squared is 1. Negative 1 plus 5 is 4. Is this greater than or equal to 0? That's true. True. All right, let's pick a number that's on the other side of 0. Let's pick 1. 1 squared is 1. We're substituting right here. 1 plus 5 is 6. Is this greater than or equal to 0? That is true. Now, so we know that to the left of negative 5 is not true. To the right of negative 5 is true. What about negative 5 itself? Let's put negative 5 in. Negative 5 squared, that's 25. Negative 5 plus 5 is 0. Is this greater than or equal to 0? That's true. So my domain for this is x is greater than or equal to negative 5, because this is where we're finding it to be true. So then you've got bracket negative 5, comma, infinity. That's the official form. All right, that's probably the most challenging that we'll see, where you have to find several different parts. All right, the next thing that I want you to do is go ahead and flip over to page 6. And we're going to look at these 3 examples here. What I'll do is I'll go ahead and create a second video to go ahead and look at these application problems on the back. So if you want to pause this point in time, and I'll have a second video for this lesson.